We're going to have a look at what are called alkene addition reactions. These occur when a small molecule like water or HX, X2, or H2 is added to an alkene. Okay, to determine the resulting molecule simply redraw the alkene, removing the double bond. Alright, so when I said H2O or HX, what I was referring to is X would be fluorine, chlorine, bromine, or iodine. This is a halogen. Basically, you form a substituted alkane. Alright, so I'm going to draw some examples. I'm going to use a butene molecule as my alkene in each case. Alright, so this is going to be 1-butene, or but1-ene, sorry. Alright, into this we're going to add, for example, HBr. Alright, so now, the only part that I want to touch of this molecule, of the butene, is I'm simply going to remove the double bond. Alright, so I haven't altered any other part of the structure. I'm simply going to add the bromine and the hydrogen to the carbons that were involved in the double bond. I'm going to rename the molecule. This is now 2-bromobutane. Now, you may want to write this down. Pause the video. Markovnikov addition. Basically, a hydrogen gets added to the carbon with more hydrogens. Pause this, write it down, have a look. So, carbon 1 has 2 hydrogens bonded to it. Carbon 2 only has 1 hydrogen bonded to it. Alright, so here's carbon 2 with 1 hydrogen bonded to it. Alright, so where does the bromine go? Where does the hydrogen go? You can see that the bromine gets delivered to carbon 2 in this case. The hydrogen went to carbon 1. That's always the case. Alright, you have a look again in this example. So this is going to be but1-ene, and we're going to add water to it. So water splits into an H and an OH. So oftentimes we may write it as HOH. So again, what am I going to do? I'm going to redraw the but structure. All I'm going to do is remove the double bond. Now, the alcohol, the OH group, goes to one carbon and the H goes to the other. The OH goes to carbon 2, the H goes to carbon 1. Now, this would be called butan-2-ol. We'll worry about the naming of alcohols later. Alright, if we were asked to reproduce something like this at this point, we would just ask that you draw the structure. We won't worry about the naming. This will most likely be after the holiday break. We'll get there. Alright, so we'll have a look at another example. This time Markovnikov's rule won't apply, okay, because we're going to add Br2. So now we don't have to worry about the hydrogen going somewhere. There is no hydrogen to add. But I'm going to handle this the exact same way. I'm going to redraw the alkene. Alright, but all I'm going to do is I'm going to remove that double bond. Okay, so there's the but structure. Now in this case, the 2 carbons that were involved in the double bond, each of them gets a bromine. Okay, so this now becomes 1,2-dibromobutane. Alright, and our final example here is a process known as hydrogenation. Okay, so again, I'm going to take but1-ene and I'm going to react it with molecular hydrogen, so plus H2. So I'm going to redraw my but1-ene and I'm going to add a hydrogen to each of the 2 carbons that were involved in the double bond. Okay, so there's the molecule I started with essentially. I'm going to put a hydrogen on each of the 2 carbons. Right, this is now just known as butane. Okay, you may want to rewrite the formula just as CH3, CH2, CH2, CH3, so you don't have the hydrogen sticking off there. Alright,